You are listening to The Vocal Technologist. Spoken Tech for your ears.
Welcome, everyone, to another exploration of how we're making technology work faster and, well, genuinely smarter. Here on The Vocal Technologist, we try to unpack the latest developments in data processing, AI, system efficiency,
Right.
all to give you a clear view of what really matters. We've got some fascinating sources today.
Exactly. And our goal is always to cut through the noise, find those aha moments for you.
Yeah.
Today, we're looking at everything from supercharging Python code to how AI is actually learning to remember things.
Yeah, and organize information. It's all about how these pieces fit together, shaping the future of data and AI.
Absolutely fundamental shifts.
Okay, so let's start with Python. Anyone knee-deep in data work knows that feeling. Your script just crawls. Speed's often the big bottleneck. But what if you could slash that runtime without rewriting everything, like almost no code changes?
Well, that's kind of the promise of GPU-accelerated libraries.
Yeah,
Think of your standard tools like Pandas for data work on a CPU.
sure, everyone uses that.
Right. Now imagine cuDF. It does the same kinds of data manipulation, but it runs on the GPU, orders of magnitude faster.
Wow.
And it's similar for machine learning. Scikit-learn is the standard, but cuML leverages the GPU for a massive performance boost. Suddenly, training complex models on huge data sets, it becomes much more feasible.
That sounds almost too good to be true. An instant upgrade.
Are there, hidden catches? Is it always just a simple swap?
That's a fair question. It's not quite magic. You obviously need the GPU hardware.
Right.
And getting the hang of memory management on the GPU can be a bit of a learning curve, especially with really large data sets.
Okay.
But the payoff, it's usually immense. We're talking swapping in tools like cuDF, QUML, XGBoost for boosting, whograph for graph stuff.
All using familiar APIs.
Largely, yes,
Yeah.
using those familiar APIs. And suddenly, your workflows aren't just faster, they can scale to problems you couldn't really tackle before.
Okay, so we've got raw speed covered, but fast processing of scattered data isn't the whole picture, is it?
No, not at all. Making sense of it, connecting the dots, that feels like the next crucial step. And that leads us to knowledge graphs, right?
Indeed. Knowledge graphs are all about identifying and linking things, entities, relationships across all sorts of different data sources.
Turning messy facts into something connected, queryable, actionable.
Exactly. And what's really exciting now are these automated workflows.
Yeah.
You can combine sophisticated entity extraction, like from models such as Gemini 2.5, with multimodal data management, maybe using something like ApertureDB, to actually build these graphs automatically.
So you go from just raw data, maybe text, images, whatever, to an interactive map of knowledge, ready for things like RAG pipeline.
Right, retrieval augmented generation, where the LM can look things up in the knowledge graph for better answers, or just much smarter semantic search, finding things by meaning, not just keywords.
And we saw that example using tools like DSPy to enrich these graphs, disambiguating entities with LLMs, even building a Nobel mentorship graph. That's powerful stuff.
It really is. It helps surface hidden connections, context, things crucial for research, or just understanding complex domains. It fundamentally changes how we interact with information.
Okay, so faster processing, smarter organization. How does this filter down into the AI systems we use every day? Let's peek behind the LLM curtain a bit.
Yeah, it really starts with tokenization, breaking text down into numbers the model understands.
Seems basic, but critical.
Absolutely critical. It affects everything. API costs, how much context the model can handle, its actual performance.
How so?
Well, think about how 3.11 might be tokenized differently than 3.9, or how code often breaks into way more tokens than plain English. It explains a lot of an LLM's quirks, especially with non-English text or numbers or code. Efficient tokenization is huge.
Got it. And LLMs are stateless, right? They only see the current prompt. So how do they remember anything? Past conversations? Or even remember you?
That's where agent memory engineering comes in. You design systems with sort of two types of memory, short-term for the current conversation context, and long-term memory. Often using these vector-enabled stores, think of them as smart databases for persistent facts about the world or about you.
Vector stores. They find some more concepts quickly.
Exactly. That allows the agent to recall relevant details, personalize responses, handle multi-step tasks properly. It's the key to making AI feel actually intelligent over time, not just reacting.
So when you look at how these systems learn and recall, what really stands out to you? How does it change things?
What stands out? Honestly, it's how memory moves AI beyond just being a clever tool. It gives it continuity.
Right.
It allows the AI to build a kind of relationship, to learn your preferences. Remember what you talked about last week?
Yeah.
It becomes a more effective, personalized partner. That's the game changer, I think.
Yeah, I can see that. So from GPU speed boosts in Python to the intricate web of knowledge graphs making sense of data, right down to how LLMs actually think and remember, we've covered quite a bit today.
We have. And these things aren't separate silos, are they? They're deeply interconnected. Better infrastructure powers smarter AI.
And smarter AI helps us manage the information flood.
It's a virtuous cycle, really.
So here's a final thought for you to chew on. With the insane amount of data being generated constantly, what new possibilities does this blend raw speed, structured knowledge, intelligent memory unlock for your work, or even just your daily life? Where do you see these pieces creating something truly transformative next?
Spoken Tech for your ears.